It just occurred to me as I started to record this again that I said we would do mode and range in the same thing, but that is no longer the case because I forgot. So, again, this is our data set. This is the statistical question we asked in math enrichment. Here's our data. We're going to use this data to help us learn how to find the range. So I'm actually going to take this back down here to the range poster. Remember that the range, and some of us might be able to tell this just because we kind of have heard the word range before in like other settings. We might be able to tell that the range is the difference between the maximum and the minimum. So the difference, remember difference means subtraction, right? And when you think of range, you might think of like a distance, right? So we're kind of looking at the distance between our lowest value and our highest value, our minimum and our maximum. So let me write that first. Our range is the difference. I'm going to put above that in parentheses a subtraction symbol just in case any of us forgot about that. The difference between the I'm just going to say the max because I'm lazy, and min, I'm lazy, in a distribution. So again, when you're trying to figure out which one's the max and which one's the min, with such a low amount of data as we had from math enrichment today because everybody was gone, it's really easy to tell at first glance what your max and your min are. However, if you had more data, it would actually be really helpful for all of these summary statistics to just go ahead and put them in order. So I'm going to put our data in order again. We have, grab a different color. Let's do this. So we had 5, 6, 6, 6, 6, 7, 9, 10. So that was all of our data. So as you can see now really easily, our lowest value or our minimum, the lowest amount of pairs of shoes that somebody in math enrichment had was 5 pairs of shoes. So I'm going to circle that. That is my minimum, or my min, because math people are lazy, we like to abbreviate. And the most pairs of shoes that anybody had, amazingly, is 10 pairs of shoes. So 10 pairs is our max, and that's really badly drawn, whatever. I just totally lost my train of thought. Well, anyway, so we're looking for the difference between our maximum and our minimum. So technically, you could do minimum minus maximum. You'd end up with a negative number, and you could ignore the negative. But it makes more sense to just do our maximum, or our max, minus our min, or our minimum. So I'm actually going to do that. My maximum is 10 minus my minimum, which is 5. So let me get that purple marker again. So the range is 10 minus 5. 5, right? The range is 5 pairs of shoes. So that tells us a little bit about our distribution. It tells us that out of the, 4, 5, 6, 7, 8, out of the about 8 students in class today, we had a range of 5 pairs of shoes. That tells us a lot about how our data is spread out across the distribution. If everybody had 6 pairs of shoes, our range would be 0, which would tell us there's not a lot of potential for differences, right? If our range is 0, there's only one possible option for the data. But because it's a larger amount, of 5 pairs of shoes, that gives us a lot more wiggle room for potentially how many pairs of shoes people had. If it was even bigger, if our range was 100 pairs of shoes, that would mean that people could have anywhere from like 1 pair of shoes to 101 pairs of shoes, right? It gives us a lot of potential for things to be different. So that's what the range is supposed to tell us. It tells us about the variability or the possible differences in our data.